Okay. Okay, fine. So yesterday where we left. Okay, so we need to start from the same point. So I hope you all uh, please go on mute if you're not talking. Mm, okay, right. So I hope you all have drawn this diagram. Okay. So yesterday what we did is we just took this 299 and this router has three interfaces. Why we added this three interfaces? Because here we required three interfaces on the router. Okay, so we took this 911 2911 router series. Okay, so it's very basic diagram. So throughout our routing, all our routing lab we will do on this lab diagram. So basically what we have India, we have India office, we have USA office, we have UK office. Okay, so India LAN is 192.168.10.0. See, you need to memorize this diagram. Okay, India LAN is 192.168.10.0 and USA LAN 192.168.20.0 and UK LAN is 192.168.30.0. Okay, clear? Then WAN. So India to USA, the WAN link is 192.168.1.0. So we have given 1.1 here and 1.2 here. So as you know, this WAN network should be in the same network. Similarly, okay, this should be WAN 2 actually. WAN 2. Okay, so WAN 2 192.168.2.0. So 2.1 here and 2.2 here. Okay, so make sure the interface which you connected, you assign IP address under that interface. Okay, and for the LAN, the gateways are configured on the router 0 gig ethernet 0 by 0. Here also 0 by 0, here also 0 by 0. So this is very clear diagram. Okay, and yesterday I think we have given some default routes, so let me remove those routes first and we will do a static routing here. So how to remove that? Show run. If you go here, okay, so we see the default route, so let me remove it. No, uh, copy, paste, done. Right? So India router, we have given default route, and then let's go here, enable show run. Okay, so we see here two routes. So we say config terminal no. Okay, copy and paste. So our diagram is ready. Copy and paste, done. And the third one is this one, UK router, uh, enable show run. Okay. Oh, so show run config terminal no IP copy paste, done. So now our basic diagram is ready. I just write memory, and here also see write memory means don't ask me what is write memory. We are saving the configuration. Okay, so we removed yesterday's lab and now this is our fresh lab. Okay, with all the basic configuration. What is basic configuration? This machine is having already IP address. The router, both interface assign the IP addresses. Here also all three interfaces of the router assign the IP address, and here also two interface, and this machine is having the IP addresses. And what else, yeah, that's it. So we this is our base diagram. Okay, so now uh, we will do a static routing. Okay, static routing, see routing means what, like we have five networks here. First, always calculate how many networks you have. So in this diagram I have one, two, three, four and five networks. So each router should have five networks in its routing table, then only the routing will be possible. Okay, so by default, remember, by default, um, India router will have two networks directly connected to each, 192.168.10.0 and 192.168.1.0. Okay, so see this class this is going to repeat third time. Okay, since 3 days We are learning this one, so you have to memorize, and without practice you will not understand. You have to practice this one. Okay, then USA router, it will have three networks directly connected. One and two, in its routing table, 192.168.20.0, 192.168.1.0, 192.168.2.0. Okay, and for UK router, these two networks, 30 dot and 2 dot. Okay, so now let's verify that. Just go and verify. See, we have remember we don't have done any routing and all. Show IP interface brief. You can check the interfaces. Show IP route. C. C means are directly connected. So one and two networks are directly connected. Similarly, go and check in the USA router. Show IP interface brief. So now don't be surprised why three interfaces, because three interfaces are used there. So whatever the interfaces, one is 20 dot, one is 1 dot, one is 20 dot, or 2 dot. So we should have a IP route in the same routes. Okay, C, C and C, 3C you can see, 20, 2 and 1. Okay, this is clear. And the third one is UK router, just verify there. So this is our base diagram. We haven't done anything, just the basic configuration we have done, and we save our configuration. So this diagram you can repeat multiple times. Okay, so show IP route. Similarly here, see UK router know about WAN link and its own LAN. That's it. Okay, now tell me, for India router, how many routes are missing here? How many routes are not connected, directly connected?
Three not directly connected.
Okay, what are those?
What are those? UK, you
You can give the name like
yes, yes.
USA LAN,
USA LAN, UK LAN,
UK LAN, and
and
WAN 2.
LAN 2.
WAN 2, exactly. So, and what will be the next hop for all these three networks? This is important because in the IP route command we use the next hop. So now just see here your India router. So if you go in the right side in this direction, right direction. So the first point, the first IP will come 192.168.1.2. Like that is the nothing but this IP address. So your gateway will be to reach this all three networks. This guy will be. Okay, so your next hop will be common for all these three. Why? Because you are going in the same direction. So let's go and view the routes. Okay, so what I'm going to do, config terminal, ip route 192.168.20.0 255.255.255.0. Next hop 192.168.1.2, right? Similarly, I am going to give a LAN of USA, and next stop will be the same. Done. And finally, the WAN 2. What is WAN 2? 2.0. And next stop will be the same. Done. So now go and check in the routing table, India routing table. So now see here, you got a three static. S means static. 1, 2, and 3. So now India router know about all these five networks. Okay, now our second job. Okay, now tell me first, USA router, how many networks are not directly connected? Give the name.
India LAN, UK LAN.
Right, exactly. Okay, now very important question. To reach India LAN, what will be the next hop? If you give the
India,
answer, static routing is done for you. Come on. To reach India router, USA router, if you want to reach India LAN, what will be the next hop?
India route in India router and
Tell me the IP address. Can it be this one? Yes, because there is no another way. That is only the next hop. 192.168.1.1 will be the next hop in the left direction. Okay, now to reach UK LAN, what will be the next hop for USA?
first LAN 2 and UK.
To reach UK LAN, what will be the next hop? So next hop will be this guy. See, the direction change, next hop change. If same direction, see, while in India it was going into one direction only. On all this route was here. This one, this right side only. So the next stop is same. But in this case, one next stop is left side, one next stop is right side. So to reach India land, he has to go here. So this is the first point, entry point. So that is nothing but your next stop. And in the left side, in the right side, if he want to UK land, then this will be the next stop, right? So let's go and configure. So how many static route we have to give here? Tell me first. How many static route? Two. Why? Because I already have three routes here: C, C, and C. These three routes. So what are missing? I just need to add that. IP route. First, let's add 192.168.10.0, 255.255.255.0. It is the India LAN. And how can I reach there? 192.168.1.1. Okay, and similarly, which network is not directly connected? 30
UK
UK
land.
LAN. And what will be the next hop will change here? Remember this point. 2.2. The next hop will be changed here. 2.2. Right? Done. So now check routing table. So IP route. So you got the two static route, one here and one here. And can you see for the static route? See, one by zero. So this is nothing but the administrative distance. Okay. So done. So now can you please answer me? Now we have the routing. So can machine 10.10 reach to 20.10? Come on, fast answer. Can machine 10 reach to 20.10? Yes or no?
Yes.
Why? Why? Because see, when this network want to reach this network, so just think about this router. India router has both the route or not? Yes, it has. Similarly, this guy 20.10 want to reach to 20.10. So can a USA router has India LAN? Yes. Okay. You can mute. Okay. So let me ping. Let me try pinging 192.168.20.10. Yes. Okay. Now we are able to ping. So can I trace and check? Always see after ping traceat command. Remember this command from machine traceat 192.168.20.10. How we are going actually? See, first it is its gateway, then next hop, and then destination. See this you have to memorize, like you have to do practice. So you must know what is gateway, what is next hop, and how it is going. So this is only understanding routing means this is only the table. Understanding the routing table, trace route. So these are all are the troubleshooting steps. Okay, our routing is entire depend on ping tracer. Okay, now next, what left? UK router. So UK router, if I go here and check, so I have two networks here directly connected. So I need to add three networks. Config terminal, and what will be the direction here? Okay, now come on, tell me. I'm in UK router. I see there are two networks directly connected, 2.0 and 30.0. So how many route I need to add here? Guys, I'm asking you.
3.
Right. Okay. Mute yourself. Some. Okay. So Mohammed, you kept silent. So the question to you: how many routes I need to add in UK router? Hello. You there?
Yeah, yeah, Sri, yeah, now.
3. Okay. Now, what are those? Can you tell me?
India land,
Right.
and one address,
Exactly.
and USA land also.
Exactly. And what will be the next hop?
Next hop will be the gig 0 by 2 interface IP address.
Exactly. Exactly. You understand static routing 100%. 100%. So understanding of this one, missing routes and the next hop. If you understand that, that is static routing in your pocket now. Okay, now. So I can add now IP route 192.168.10.0, 255.255.255.0, 192.168.2.1. Then I need to add the USA LAN. The next hop will be the same, and I need to add the WAN one, which is not directly connected. 0. Next hop will be the same. Done. Show IP route. Can you see? I have a 3 static routes now. Okay. Now, okay, let me go to UK machine and try pinging the India machine, India LAN. So first check IP config. So what is I'm here at 30.10 and my gateway. So first try pinging. It's your own gateway. 192.168.30.1. Are you able to reach? Yes, I'm able to reach. So let's go one by one. Let's try pinging USA LAN 20.10. Is I'm able to ping 20.10? Yes, I'm able to ping. So also, okay, let's do one thing. There is no, in Linux we have clear command. Okay, now listen very carefully. Let me first check once again IP config, the IP address of this machine. Okay, let's ping the gateway 492.168.30.1. Yes, it's pinging. After ping, just do the trace to the same IP. Trace at 192.168.30.1. See, trace means it's going directly to the gateway, right? First, done. Now let's ping the USA LAN. Are you able to ping? Yes, I'm able to ping. So now, can you tell me how many next hop will come while tracing 192.168.20.10? Can anyone answer? Fast.
3.
Okay, let's see.
2.
3 means see the third is actually directly a destination. So 2 only. So it's going to its gateway, then it's going to the next hop and the final destination. Now let's
Yes.
try pinging. Let's try pinging 30.10. I'm able to ping. So can you answer me how many next hop will become here? Come on. Who will
2.
answer? He know the static now. He understands static routing. How many?
2. 2.
Okay. Before seeing that, can you tell me the by looking the diagram? See, I'm here. I'm here, and I'm going to ping this machine. Now tell me first. So how many next hop will be here from this machine?
Will be
What?
2.
Okay. What will come first? What will come first when I do the tracer?
192.168.2.1.
No, 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 no. First, its gateway will come. 30.1.
Oh, yeah, sorry. Yeah.
Right? Next. What next? After this?
192.168.2.1.
Exactly. It will come. What next?
Will be 3. 192.168.1.1.
Exactly. And finally, it will reach here. See? Let's see on PC3. Reset. Oh, sorry. Where I am? I am in. Let me open the same machine. PC3 only, right? Yeah. So tracer to 192.168.10.10. See here. Whatever you said, the same, the command is same. It reaches to the gateway, then the first next hop, then second next hop, and finally reach here. Right? So this is a static routing. Very, very clear. Only remember the point. See, very quick point you need to memorize. I will just move down here. What the main thing in static routing? Static routing. Okay. First point. The first point is see the directly connected network, or you can say missing route not directly not directly. We'll say add. So first point, add route not directly connected. See what we did in India. Now you need to understand what are directly connected. So how you can see show IP interface brief or show IP route. So you will see what are those directly connected. What are not connected? USA LAN, UK LAN, and UPAN LAN. So you need to add those routes. Second point, very important, next hop. Next hop. Okay. So next hop will be the same. So the one more point to remember about next hop is direction change, next hop change. That's it. So these points you need to remember about the static route. So direction change, where the direction got changed here in USA router, while reaching to India, the direction got changed. It is going left side. So that for this next hop is this one, and the same thing to reach UK, next hop is this one. That's it. So now you understand static routing, and yesterday we have seen the default routing. Default routing. See, okay, let's do one thing. So default routing. See, in the default routing, it's very simple. You no need to do anything. Okay, if you know destination, okay, what you need to do in the default routing, what you need, only next hop you need to know, because the ISP will give that next hop. If you don't know that, at least the exit interface of your network, exit interface of your router. So for India, what is the exit interface? Giga 0 by 1. For USA, this left side, what is exit interface? 0.1. Right side, 0.2. And for UK, exit interface, if you want to reach it, go here, 0.2. So see, generally, one more thing, point to be noted. Default routing we don't use in our LAN. Okay, it is for the internet only. I will write down here. Only for internet. Right, can you take this picture and send in the group, please? Okay, only for internet. Okay, so remember this one. So
Sure, inshallah.
okay, so this machine IP address I'm not using. Okay, so what we will do? Let's do. What is this? Okay, so let's remove this static route. So now you understand the static route. Okay, so I can remove the static route. Okay, one more time you can see show IP route. See your routing table. So S. Can you go on mute, please? Shahid?
Sorry.
I muted myself. Sorry. Okay, so what I can do, let's do the static routing quickly. Again, a default route, because yesterday we have seen. Again, tomorrow I'm going to show you today. So you will understand very clearly. Show run. So what I will do in the same diagram, see, now I want to remove this 3 route. So what I can do, I can use the notepad. Always use the notepad. Notepad. And see, and just say no. No. Then here no. Then here Just copy it, go to India router, config terminal, just paste. See, we use lot of notepad here. So see, if I save now, see my old configuration came back. So nothing here. Now my base configuration came here. So I need to remove the routing from here also. Static route. So how many route was there? So two. Show run. Config terminal. So either you take one by one, copy paste, or just you can just copy it, put it into the notepad, put it into the notepad, and just say no. And here also no. Okay, and copy it, copy back, config terminal, and put it here. Done. Similarly, save the menu. Right away. So now your old configuration came back. And now go here, show run. So three routes are here. So just copy it, copy, then go here, notepad. See it. I'm saving my time actually. So you know what? During CCI, the CCI lab is the 8 hours lab. So when I was doing my CCI, so we need to use lot of notepad. Otherwise, so hundreds of command you need to type, write, and there will be 18, 20 routers will be there. So how you're going to go and do one by one? So we use the notepad. So it will save your time. Okay, but it is after some level, not in the starting only. So don't try directly if your initial thing first time you are doing, and don't try notepad. Okay, now done. So right memory done. So my static route removed. So my question to you: can I ping now? Can I is I'm able to ping to see now see the ping result 20.0. What see the router is saying destination what reachable. It reaching okay till where it is reaching. Now try to compare. See it's reaching to its gateway first. Gateway is nothing but the router, and router don't have the routes. See, remember here in previous scenario, see it we were able to ping, right? We were able to ping 20.0, 20.10. How we were reaching? First gateway, then next hop, then here. But now we remove the routes. So now see here, destination host unreachable. Router is dropping the packet, and when we do trace, see our packet is going till the gateway only. See, this is the networking understanding. Okay? So very clear. Okay, now let's use the default route. So one more time I'm telling you, default route we don't use the LAN. Okay, but to understand generally what we can do, uh, okay, let's do one thing. Okay, in the same diagram we will use just for our practice. What we'll do, instead of static route, we will use the default route and we will test it. Okay, generally we do default route for one time. Okay, so what I need a next hop or either exit interface default route. So what I will do, I will directly go to India router, show IP route, check here. So I don't have any route on, just directly connected. I'm going to add the default route. What is default route? 0 dot okay, IP route 0.0.0.0, any destination 0.0.0.0, any subnet. Okay, question mark. See, you have the options. Either you can put the next hop, you can put the Ethernet, fast Ethernet, any gateway. So let's try here fast Ethernet 0 by 1, the exit interface. Not fast Ethernet, Giga Ethernet it is. Giga Ethernet 0 by 1. See, if I put here, it may give the error. See, it's saying point interface may impact performance or something. So I can just go and remove this. No, invalid number it is saying. This is not not available. So Giga Ethernet 0 by 1. Giga Ethernet 0 by 1. Okay, fine. So this maybe this router is not supporting. I'm matching that to the loop. sorry. See what I did. I use a no and I try this side, this one. That's why what it is saying not match route. So there is no route actually what you are going to delete. So now this is the correct one. Exit interface. So default route without gateway. If not, a point-to-point interface may impact performance. Okay, it is giving the error. So prefer always a gateway. Okay, but still we can see show IP route. Can you see S? So what we are giving, it's saying directly connected to this one. So what will happen whenever the unknown packet means 192.168.20.10. So the first router will see is it available in routing table? No. Then it will reach to default. This is the least preferred route, S star, and it will just pass to Giga Ethernet 0x1. So another router will take care of that. Okay, done. So here this side also. Let's do one thing. This side, uh, we will use. Actually, this is not a good practice to use the default route on the both side of this one. So generally the ISP, but just for our lab purpose, we will perform this. Take this step. Interface IP route 0. Sorry 0.0.0.0 there will be one default route only in the routing table, but just for having the practice we are using this. Here let's use the 192.168 or 168.1.1 next hop. Done. And another route, see we don't use two default route, but here for just for understanding we are giving here. So another is right side 192.168.2.2. Done. So IP route. So we see here the two default route I have, and here this side again on terminal IP route 0.0.0.0 then question mark. Then what is the exit interface? Giga Ethernet 0x2. So I will say Giga Ethernet 0x2. Done. Now check the show IP route. So now let's do the testing. Okay. So what I'm going to do first, let's ping UK 192.168 USA from UK to USA 20.10. Done. It's pinging now. So if I do a trace search, how it is going? Trace search. First gateway, then in the routing table, now it is saying router is saying, so no, I don't have 20.0, so I'm just passing it to my gateway. Next hop. See, so it said request timeout to the exit interface, but it reached here. So what happened actually? So when the traffic came here, so this guy said I don't have 20.10, so I'm just passing here. It went here and from here to here. That's why you remember while giving the exit interface what it told, use the gateway, right? So now let's try from here. Okay, now on the same machine let's do the testing. So on the same machine, let me try ping 30.10. Oh, sorry, 2.10. So 10.10. 10.10. So it's pinging, right? It's happening via default route. See, now if I do the trace route, to the same tracer. See, first it needs to gateway, then it will say request timeout, and finally. Okay, now, meanwhile, the question to all: static and default routing, which is the easiest one?
Static.
Static, but in a static, you need to add three routes from in India router. But here I just added one route. See, India
Follow
router,
this one.
yeah, for India router, if I go and check show run, see, I just added one route. But previously, for static route, I need to add the three routes. So both are like for static routing, it is a manual configuration, and you need to know all destination. But see here, for the default, you don't no need to know about the destination, just 0.0.0. That's why we use it for the internet, because we don't know the Google, Yahoo, then YouTube and all these IP addresses. That's why we use 0.0. And the internet, that's why in the internet we are reaching everywhere. See, if you have internet connection, you can browse anything, you can go anywhere. There is no nothing. Okay, but in our LAN, so if you put 0.0.0, the default route, so it means you are allowing any threats. So from security point of view, this is dangerous. Okay, so do this lab static. We understand the static routing. We understand the default routing. Any doubts here?
In organization, which one are used? Default or
wait, wait, wait,
static?
wait. So now we just has the two steps. Now let's
Okay,
go.
okay, okay.
Let's move to the third step. Then I will answer your question. Okay.
Okay. Because default is more threats too.
Yes. Okay. Now see, we
This
haven't
is
touched the
open
dynamic.
source.
Yeah, we haven't touched the dynamic. So let's see the
Yes,
dynamic.
yes.
Then we will. Then you decide which one will be good. Okay. Now static routing done. Default routing done. Now the dynamic routing. Let's move to dynamic routing. So in dynamic routing, so today I'm not going to take any lab, just a theory I'm going to explain. Tomorrow we will start the dynamic routing labs. Okay, for the dynamic, see, dynamic means what? The static means manual, dynamic means automatic. So remember this point. Dynamic means automatic, you no need to do anything. Okay, so in the dynamic routing, so there are the routing, so the protocols we use, what is mean by what is protocol? The protocol is nothing but a set of rules we have seen in STP, VTP, then in the ether channel we have seen LSCP, PAGP, right? So what are these? These are the protocols. Protocols is set of rules. Similarly, in the routing we have the protocols. So routing is broadly defined in two groups: IGP and EGP. Listen very carefully. IGP and EGP. IGP operate within autonomous system, and EGP connect different autonomous system. So what is autonomous? Now the question is, what is autonomous system? Autonomous system is a set of group. Okay, autonomous system is set of group, one region, or you can say set of one group. So IGP. So protocols are two types. One type is IGP protocol, interior gateway protocol, and exterior gateway protocol. So in the interior gateway protocol, so these are the protocol we use in the IGP: RIP, OSPF, IGRP. This is the dead one, and EIGRP. So these three: RIP, OSPF, EIGRP. Okay, these three protocols called IGP protocol, interior gateway protocol. They use within autonomous system. Okay, here also you can see there are two autonomous system here: 100 and 200, two autonomous system. So here we use this three IGP. And for EGP, exterior gateway protocol, so there is one protocol only, that is the big one, that is called BGP, border gateway protocol. So this is actually also called a internet protocol. So BGP used to connect two different autonomous systems, and Within autonomous system, we use RIP, OSPF, and EIGRP. Okay, we will learn more regarding this. So remember this point: IGP and EGP. And in IGP we have RIP, OSPF, EIGRP, and EGP we have one protocol only, that is called BGP. Okay, what is autonomous system? Autonomous system, a unique number identifier of the routing domain of the routers. So ranges from 1 to 65535. So in the autonomous system also there are two types, public and private. You remember the public IP address and private IP address. Similarly, autonomous system also owned by some organization. So if you want to use within your organization autonomous system, so we should use 64513 to 65535. This range, between this range. And rest of this one you need to purchase. These are the public autonomous system. You need to purchase that. Okay. Next. Okay, routing classification, IGP and EGP. Interior gateway protocol, this is exterior gateway protocol. A routing protocol used within autonomous system, this is routing protocol between autonomous system. All routes will routing within same autonomous boundaries. Here routes in different AS near the EGP. So example, RIP, IGRP, EIGRP, OSPF, ISIS. So these are the protocol, IGP protocol. These are the, in EGP protocol only one, that is called BGP, Border Gateway Protocol. Next, dynamic routing. What are the advantages of dynamic over static? Okay. Next, now think this point very carefully, listen here. So the dynamic over static. Okay, the first thing, there is no need to know the destination network, right? This is the good advantage. Next, need to advertise the directly connected networks. Now see, do you see any reverse sentence here? In static routing, just remember what I write here. In static routing, add route not directly connected. So what we did in static routing, we add what are not directly connected. This one, and this one. And you know what dynamic routing is saying? Just advertise directly connected network. What is directly connected network to India? This one and this one. So you just need to advertise that in the self router. You just need to self advertise. That's it. You no need to know about the destination and all. Okay, we will see in the lab. You will understand. Okay, the need to no need to advertise directly connected network. Update the topology changes dynamically. See, in the static routing, if you remember here, see, yesterday, day before yesterday, we had India office and US office, right? So we did a manual configuration. Then yesterday we added UK network. So what we did, we have to add the UK LAN here, right? Similarly, if I add another router, Africa router, so those again two network will be added. So I need to add those two networks again in all the remaining routers, right? But here in dynamic, you no need to add that. So what will happen? Updates the topology changes dynamically. Dynamically, if any network added, it will go to all the network, all the routers dynamically. That is why I told this is the automatic. Then administrative work is reduced. See, administrative work is reduced. This is a one-time configuration. Just do it. That's it. And if you add new networks, automatically it will get added. Then use for large organizations. Dynamic routing used for large organizations. And neighbor routers exchange routing information and build the routing table automatically. So this is very important point. So in the dynamic routing, see, in the static routing, what was happening? You need to go manually and define what are the missing routes, right? But here, what you need to do, you just need to enable routing protocol in India router and US router. Okay, so what will happen? These both router will become a routing. They will become a neighbor. So what will happen? This guy will, whatever its routing table, it will send to him, and whatever its routing table, it will. So they will exchange the routing table. If suppose to this side there are some another networks connected, this side some another networks connected. So these routers both they will exchange the routes like this. You no need to worry about what missing. So they will exchange the route automatically in the dynamic routing. Okay, so understand dynamic routing. So now dynamic routing again classify into, okay, now we are Okay, so these are the two major categories, IGP and EGP in the dynamic routing. So in the IGP, again IGP is classified into three groups. Okay, the first group is distance vector in the IGP, distance vector protocol. So works with what a distance vector protocol works with Bellman algorithm. So there is an algorithm called Bellman. It is used in this protocol. Periodic update. Periodic update means there are some certain time, okay, 30 second, 60 seconds. So router will exchange the routing table. Classful routing protocol. This is a classful means it will not understand the subnetting. Subnetting we haven't touched. We will see. As I told you, subnetting is, this is one of the topic which I take after switching and after some routing. Why? Because you will not generally what happen, the people they take subnetting in the first 5 classes. So everyone will lose their interest. Oh, this is because this is mathematical calculation. So you will forget that. So but the submitting we will see after this. So you will understand very clearly why the submitting is required. Okay, so classical routing table. So this, it don't support full routing table exchange. So what will happen in 30 seconds, the router, India router and USA router, they will exchange the routing table continuously in every 30 seconds. And updates are through broadcast. Broadcast means you remember in IP address we have seen there are the private address, in the private address, public address, and there is something called broadcast address. Okay, broadcast address it is reserved to 23 dot something. So though those subnet is reserved for the broadcast. So they exchange the routing table via broadcast. Okay, so this is a distance vector protocol. Next is uh, the another big thing is link state protocol. Distance vector protocol, link state protocol. So link state protocol, what it does is it work on a Dijkstra algorithm. Okay, distance vector protocol, it was working on Bellman algorithm. This is working on Dijkstra algorithm. Link state update. So it is again quicker. What it say, it is not updating entire routing table. It is just link state update. If something went down, it will update. It is a classless routing. It supports the subnetting. And you know what? Missing routes are exchanged. If you remember here in the distance vector, full routing table are exchanged. But here only the missing routing routes are exchanged. And updates are through multicast. Okay, so here broadcast, sorry, sorry for that. So that 223, that is actually for the multicast. So broadcast means, so what will happen? The router, they will broadcast the routes to every neighbor. But here, the multicast IP is reserved. So India router and US router, they will just exchange to update to the update on that particular address. So the example is OSPF and ISIS. ISIS, it is the ISP used by ISP in MPLS network. So we will see the OSPF. OSPF is the using the enterprise. So OSPF, it is called a link state protocol. In the link state protocol, OSPF is the example. And distance vector protocol, RIP. See, RIP, it was started RIP version 1, then version 2. And IGR, right? This protocol is dead, and RIP version 1 also dead. So only we have RIP2, RIP, Routing Information Protocol. So in the distance vector protocol, we have RIP2. And the third one, which is the last, that is the hybrid protocol. You know, see, in the distance vector protocol, some advantage, some disadvantages. So whatever the problem here in link state protocol, those problems got solved, but it has also some problems. So in the hybrid protocol, all the advantages from distance and link state it solved here in the hybrid protocol, also called advanced distance vector protocol. Okay, work with a dual algorithm. See, Bellman algorithm, the Dijkstra algorithm, and now this one is a dual algorithm. Link state update, classless routing table, missing routes are exchanged, update through multicasting. So whatever the problem was here in distance vector protocol, it solved all this. And only one protocol is the example, that is called EIGRP. Okay, so let's quickly revise here. Let's quickly revise here.
Excuse me, Nadim sir.
Yeah, I know.
Yeah.
And just in 2 minutes I will just will finish it. Okay, so let's routing, dynamic routing, the IGP and EGP. Okay, and in IGP again three categories: distance vector, length state, and hybrid. Okay, so let me just this is for your understanding only. Let's say this. See, this is not topology. This is just for the tree, just to remember. Okay, I'm just going to write here. So I will say, oh, sorry, this is a big one. Come on. So dynamic routing. In the dynamic routing, IGP, interior gateway protocol, and this one is EGP, exterior gateway protocol. Okay, IGP again defined in distance vector protocol, DVP. I'm writing short name. Distance vector protocol, then link state protocol, LSP, and again this is called a hybrid protocol, HP, or it is also called advanced distance vector protocol, ADVP. Okay, so the example is RIP. This is the protocol which we are going to use. OSPF, open shortest path first, routing information protocol, and EIGRP. This is the protocol which we are going to use. Enhanced interior gateway routing protocol. And in EGP there is one protocol only, that is called BGP. It is also called internet protocol. That's it. In the routing, you need to learn these protocols. So these three protocol we will see, and BGP, it is a very big protocol. It used in the internet. Okay. So Shahid, also can you take this picture and send in the group? So this is nothing but the summary of the dynamic routing. So tomorrow we will see each and every one. Like RIP, we will discuss in detail. We will see the lab. Then we will see the OSPF and we will see the lab. Then we will see the EIGRP and we will see the lab. And now after these three, you will answer me out of these three which is the best. And you know we choose one protocol in our organization. And this BGP we will also touch this one. This is the big protocol. It has, there's a separate course in the Cisco for BGP expert. So it is a big protocol. So in enterprise we use this, and BGP used to in larger organizations. Okay, so that's it for today. So tomorrow is Friday. Can we? I think we need to take after prayer. No, after prayer, the Zoom link is not available. Okay, Mohammed, is it possible for tomorrow 1 hour early?
I work, honestly. I work.
Sorry?
Because I work afternoon tomorrow. And if I wake up early morning, it's very difficult. I don't know.
Okay, fine.
Okay, I will try.
But very
it's
important.
Recorded, huh?
We are recording, but I don't want you to miss the class. So this is very important.
So tomorrow I'm on duty.
Okay, after this, after 2:30, you need to go to office.
Yeah, because what time you said? 2:30?
2:30.
2:30 Indian time?
Yeah.
2:30 I'll be available, yeah.
Okay, fine. Okay. Yeah. So, but okay, Shahid, stop the recording, please. So what we will do, we will take 2:30 or 3 p.m. But